Very good morning. Today I want to present about our team project, communication in power system. The table below shows the list of our group members. Muhammad Aziz bin Ismail, Muhammad Badruzzaman bin Ali, Nur Aiman Syafiq bin Muhammad Rostam Effendi, Vinat Anak Leki Maisuren. Our presentation slides consist of introduction of SCADA system until application of SCADA. Introduction of SCADA. SCADA stands for Supervisory Control and Data Acquisition. It is also grown in popularity since the 1960s due to increased equipment monitoring and control requirement. Control systems that include computer for high-level process, supervisory management, networked data communication, and graphical users interface. It is also well renowned for managing a variety of operating interfaces which possible to issue and monitoring process directive. SCADA systems are used in the construction industry to operate and manage project-driven activities. SCADA system used to monitor and manage the machinery utilized in the manufacturing, production, research, and fabrication phase. SCADA system also known as a optimum efficiency at a lower costing. Next, the configuration of SCADA system. There are three configuration, which is small PLC SCADA system, medium PLC SCADA system, and large PLC SCADA system. For the small PLC SCADA system, it is recommended to use the model system to support a data switch site at a distant location. Oftenly includes a single backup diesel generator and a single service transformer. This facility system didn't meet the dependability and availability standards set for bigger facilities. For the medium PLC SCADA system, recommended to support a primary computer facilities, which consists of several service transformer, backup generator with paralleling switchgear, one and more sizable uninterruptible power supply, that's a UPS system, and numerous refrigeration units together with supporting auxiliary machinery. Facility of this magnitude and redundant distributed control architecture should be used. For the large PLC SCADA system, the mission and dependability requirement of each facility must be met by the distribute control. As the distribute control is a huge system providing a multi-facilities sites made up of several installations. It is also proposed that the on-site communication network have redundant and separate part of communication. That's all from me. Thank you.
Assalamualaikum and good day. My name is Muhammad Aziz bin Ismail. I will present about the SCADA architecture and also SCADA major components. Okay, let's take a look for each architecture first. The first one is hardware architecture. There is only one personal computer at the SCADA station. Remote telemetry units, RTUs or programmable logic controllers, PLC, are used to connect the device and the data servers together. For communication between device and the master station in the system, local area network, LAN, and also wide area network, WAN, are used. PLCs or RTUs that transform sensor signals into digital data are connected to the sensors, and RTUs use electrical impulse to activate relays in response to feedback. We can see the figure of hardware architecture at the left side in slide. Next is software architecture. This involves servers are in charge of managing and collecting data and are mostly utilized for real-time database and multitasking. This system software architecture is made up of applications that provide training and diagnostic data. The organization of information such as logistical data, in-depth schematic of particular machine or sensor, and troubleshooting menus are also made easier with use of programs. We go to the next part, which is SCADA major components and its function. The first one is human-machine interface. It's an input-output device that displays the process data for a human operator to control. It is used to provide management information such as plant maintenance procedures, intricate schematics, logistical data, trends, and also diagnostic data by communicating to the SCADA system software, program, and database. Next is supervisory system. Smaller SCADA system, the master station or supervisory station only requires a single one PC, but in bigger SCADA systems, the supervisory system include distributed software applications, disaster recovery locations, and also several servers. Then, programmable logic controllers, number 3. PLCs are linked to the sensors in the SCADA system and acquire the sensor output signals and transform it into digital data. PLCs are utilized instead of RTUs due to its benefit over RTUs such as flexibility, setup, versatility, and also cost. After that, remote terminal units, also one of the SCADA main components. RTU is a physical item that are connected to the electronic gadget with a microprocessor in SCADA systems. These devices are used to provide telemetry data to the supervisory system and receive messages from the master system by managing the linked items. Another one is communication structure. There are two terms which are synchronous optical network SONET and also synchronous digital hierarchy SDH are widely used for major systems like power plants and railroads. The use of SONET is to send a lot of data across comparatively longer distance using optical fiber. In other point of view, SDH is employed in the telecommunication industry and the basis of its feature is high order multiplexing. These two communication protocols provide information only when the supervisory station pulls the RTUs. The last one is SCADA programming. SCADA programming is used for constructing maps and diagrams, which will deliver a crucial piece of situational information in the event. Programming for SCADA may be done in C language or derivative programming language. Okay, that's all from me and thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Badrul Zaman bin Ali. So today I will continue our presentation. Next part is SCADA Communication and Protocol, Distributed Network Protocol DNP3 and International Electrotechnical Commission are two categories which is significant to SCADA protocol. First, DNP3. DNP3 is a collection of communication protocol used by parts in process automation system, such as those found in chemical and utility plants. DNP3 is designed to facilitate communication among many types of monitoring, data collecting, and control system. This protocol, also known as the Inter-Control Center Communication Protocol, is a crucial component of SCADA system that connect RTU and IED. Next, IEC Standard 60870. IEC Standard 60870 is a frequently used to operate various process facility and electric power transmission grid. Through established protocol, this standard can be utilized to interoperate different pieces of equipment from different manufacturers. This 6 component of IEC Standard 60870 define general information about the standard, operating circumstance, electrical interface, performance standard, and data transfer. A communication profile for a telecontrol message between two systems and two directly coupled is provided by IEC 60870. Through connected telecommunication, this protocol offers telecontrol and teleprotection of electric power network. Next part, the protocol used in SCADA application. High-level data link control, HDLC, and Modbus are the two extensive utilized protocol for SCADA application. A bit-oriented code, transparent, synchronized data link layer protocol called is high-level data link control was created by ISO. Both connection-oriented and connection-less service are offered by HDLC. Although HDLC can be used for point-to-point, multi-point connection, synchronized balance mode, which use one-to-one connection is preferred. It serves as a foundation for all current protocol. Modbus, originally released by Modicon in 1979 for use with its programmable logic controller. It is a serial communication system that straightforward and reliable. Modbus protocol is now a widely accepted standard for linking industrial electronic device. Multiple devices linked to the network via a RTU in SCADA can communicate with one another due to Modbus, which is with this protocol, the link element or device can be active by the master key sending from a Modbus command. Next part is contribution of SCADA system in power system. First, SCADA for power station. For each process involved in running a power plant, we can offer the best solution using complex control framework. Using PLC, a reliable bus communication link, SCADA software and hardware. It regulates several processes in generating station, including protection, monitoring, and control. In power plant, some of the most important SCADA functions are as follows. First, the frequency and the speed of electrical machinery are continuously observed. Second, geographical monitoring of water treatment and source supply technology. Third, active and reactive power control, and lastly, in case of thermal plant, the state and protection of a boiler and turbine. Next, SCADA in transmission line. When compared to the data from SCADA system, transmission line matching circuit model attribute are frequently incorrect. This mistake result in improper economic dispatch without a SCADA system, which risks cost or result in incorrect billing. Several critical SCADA duties in an electric transmission system include the following. First, service for station maintenance and rerouting. Second, direction between safety relay. Third, voltage regulation for the load tech changer control, and lastly, transformer management. Next, the advantage of using SCADA system. By using SCADA system for power distribution have several advantages, as boost security, does not require manual data collection, alarm and ongoing system-wide monitoring let operator identify and promptly fix the issue, and centralized database and system parameter history. And lastly, I will explain the limitation of SCADA system. Due to the multiple vulnerability in the communication network, securing SCADA system in power utility context is difficult. To save money and advanced technology, larger SCADA systems are linked to another network like the internet. Due to the interconnected SCADA system is the power grid are subject to a variety of communication security vulnerabilities, including insider attack, denial of service attack, man-in-the-middle attack, and social engineering assault. The objective of the attackers is to destroy network security element, including availability, confidentiality, and integrity. And SCADA system installation is costly and time-consuming. In addition to providing security, cost goes up when SCADA software is updated, and staff members are trained to use the new program. A new system could include components from various vendors that communicate via various proprietary protocols.